All right. Tonight we're just going to look at how we can factorize algebraic expressions. Then we'll also look at equations, equations and inequalities. But I think in tonight's lesson, we'll just look at the first part there and even equations, just normal equations. Then in the next session, that's when we'll look at inequalities, and then we'll go further and look at linear equations and conclude by looking at quadratic and some of the polynomials. All right, so let's quickly begin. Okay, so I'll first start by introducing you to what are known as the difference of two squares and the difference of two cubes. And so those are some of the things that you need to know. More especially if you are solving equations. There are times when you'll be requested to factorize something that is, for instance, in the format, something that is in the format, maybe you have something a squared, like a squared minus b squared. Then you've been told to factorize this, or perhaps you are solving a question, then you find something like 4, should I just say, maybe find something like 81 minus 49. Then you want to use, or let me just put it general. Let me just say it in general to say you are subtracting two perfect squares. Yeah, so you know that 81 can be written as 9 squared and 49 as 7 squared. Then you want to subtract this. How do you do the subtraction? So it's very easy to do that if you know how to deal with the difference of two squares. So when you have anything that is in this format, a squared minus b squared, this can be written as a plus b, then multiplied by a minus b. In the same way, if you have something like this example I gave, which is 9 squared minus 7 squared, as long as you are subtracting two squares, two perfect squares, what you just do is that you take the first one and the second one, put them in brackets. Yeah, so you have 9 plus 7 in brackets. You also put 9 minus 7 in brackets. So this is what you're going to have. Then 9 plus 7, this will give you 16. You're multiplying 16 by 9 minus 7, which is 2. Yeah, so this is simply just going to give you 32 as the solution. Yeah, so it's as simple as this. Yeah, so this is what is called the difference of two squares. But there's also what is known as the difference of uh, two cubes and the sum of two cubes. So when you have something like a cubed minus b cubed, this is known as the difference of two cubes. When you have something like a cubed plus b cubed, this is the sum of two cubes. Yeah, so let us see how you can work these out. So this is what I'm just showing you. This is the difference of two squares. Then about the cubes, this is what we have. So you can also master this if in case maybe you okay, you just have to know it. Let me put it this way. You have to know this in case you find anything that is in this format as you are solving a question, you can simplify it in this way. Yeah, so this is also helpful on quadratic functions. Yeah, so you'll see how we are going to be simplifying quadratic functions. So sometimes you are going to be finding questions like find the solution of or maybe let's say the question is given that the equation x squared plus 2x minus 3 has the roots alpha plus alpha and what? Alpha and beta. So I'm sure you've seen some questions that are in this format. And then they ask you to find the solution for alpha squared plus beta squared. So if you want, you can use this. Okay, we're talking about the difference. So if they ask you to find alpha squared minus beta squared, you can use Yeah, you can, there's a way you can use this to find the solution for this. Yeah, it's simple, but this one is simply, yeah, this one has, let me just mute this. Okay, but this one has its standard equation that you are supposed to use, but there's a way that you can manipulate this same expression here and find the solution for this. Then there's also something like alpha cubed minus beta cubed. They ask you to find this. This one, using the normal way of finding it, it would take you minutes, a lot of minutes to solve it. But if you apply this formula here, it's going to be helpful to you. Yeah, so same applies to this part here. When you have alpha cubed plus beta cubed, these alpha and beta are called roots of quadratic equations. So we're going to learn that as we progress. Okay, so this is very important. These two formulas, you have to master them. So the simplest way to master this is, you know that if there's a plus there, you always have a plus there. There's a minus there, you always have a minus there. Yeah, so that's the way it is. And then if there's a minus there, everything in the second brackets will be plus. And then if there's a plus there, you have a minus in between there. Okay. So we quickly proceed. Then let's look at some of the examples. Okay, you have this question here. They're asking you to factorize this question. How do you do the factorization? So you have 9x squared y squared minus 6,4. So now they're asking you to factorize this equation. So do you agree with me that this 9 can also be written as 3 squared? Yes. And then you have x squared and y squared minus this 64, it can also be written as 8 squared. So this whole function here can be written as 3xy. So in brackets, I'm factoring out the squared. I'll put the squared outside, and then we say minus 8 squared. Yeah, so this is what you have. So this is what we are going to take. Oh, sorry for that. I've mistakenly deleted. Okay, so we have 9x squared y squared minus 64. So I said this can be written as 3 squared x squared y squared minus 8 squared. So as we can see, we have we have all these squares and there's a minus in between there. So this part here, the first part can be written as 3xy in brackets, and then we have a squared outside. Then we say minus, we have 8 there squared. So this is now in the format of the difference of two squares, because we know that this first part is a square, even the second part is a square there. So now there's a minus there, and that tells us to say we're finding the difference of two squares. So I'm going to follow this same format, which is here. So in the first set of brackets, I'm going to put a minus b. And then in the second set of brackets, I'm going to put a plus b. But one thing you have to understand is that multiplication is commutative. So you can either start with a plus b and end with a minus b. The solution is still going to be the same, because multiplication is commutative, meaning when you change the position of the two functions here in brackets, you still get the same answer. All right, so we have this. So this part here, which is 3xy squared minus 8, I mean this whole part here. So start with the one with the minus according to that format. So I'm going to write, let me at least start with this part here from here. So we have 3xy minus 8 in brackets. Then I'm going to have 3xy plus 8 in another set of brackets. So this is the solution. We have factorized. It's as simple as this. Okay, we move on to the other one. So we have this other question, which is x to the power 3 minus 8. How do we factorize this? So when you look at this, I'm sure you can see that this 8 can also be written as 2 to the power 3. 2 to the power 3 is just the same as 2 times 2 times 2, which is 2 times 2, 4 times 2, which will give you 8. So you are going to have x to the power 3 minus 2 to the power 3. So when you look at this expression here, this is called the difference of 2 cubes, because we have x there which is cubed and 2 which is cubed. So we're going to get this format down here to solve the question. So this format there is, according to that format, we have x minus y in the brackets. So we're going to put x minus 2 in the brackets. And then in the other set of brackets, the first x there, so we have x there. The first number there is the one that we're getting as x. And then the second number is the one that we're getting as y. So we have plus x times what? Y is 2. And then we have y to the power 2 plus y to the power 2, so which is 2 to the power 2. So okay, so someone is saying they are struggling with network. All right, I'm going to send the recorded session immediately after the lesson. So we have x minus 2 there. And then in another set of brackets, we have x squared. 2 times x, this gives us what? 2x. And then 2 to the power 2. So 2 to the power 2, the solution there is 4. So this is what we have. Okay. All right, so that is how simple factorization is. So we quickly move on to the other question. So we have this other question which says simplify completely. So it's also a very simple question. All right, so it's also a very simple question. So the numerator there, we can factorize, or we can factor out 2 from the numerator. So when we factor out 2 there, you're going to have 2, then open brackets, you have x cubed, and then minus, when we divide 54 by 2, that is going to give us what? 27. So I'm going to put 27 there. And then the denominator is going to be x squared plus 3x plus 9. So factorizing this down here, yeah, so I'm going to do it quickly, and I'm going to, okay, I'll do it step by step, but we're going to learn properly how to factorize quadratic equations when we, in the next session that we're going to have. I'm sure that's the session that we're going to discuss quadratic equations. So we have x plus 3x plus 9. So factorizing this is simple. First of all, you have to find what is known as the product. So the product is found by multiplying the coefficient of x squared, which is 1 in this case, and the constant. So when you multiply 9 times 1 there, the product becomes 9. So 1 times 9, the product is 9. And then the sum is simply just the number that you have there, which is 3. So we find the factors, meaning we find 2 numbers that if we multiply them, they are going to give us what? 9. And if we add those 2 numbers, we are going to get 3. Do we have any 2 numbers that we can do that? Okay. Do we have any 2 numbers that we can multiply to get 9, and then when we add, we get 3? But I think we don't have. Okay, let's start with the numerator first and see what we're going to get. So on the numerator there, on the numerator we have x to the power 3 minus 27. So x to the power 3 minus 27 can also be written as, it can also be written as, first we have 2, and then the difference of 2 cubes, if you remember, we said the first set of brackets should have a minus. So I have, before we do that, let me first show you that this is a difference of 2 cubes. Okay, let me just get rid of this. So we have x open brackets. We have x cubed minus 27 can also be written as 3 cubed. 3 times 3, the answer is 9. Times 3, the answer is 27. That's why I've written 3 to the power 3. Then down here, we'll still have x squared plus 3x plus 9. So when you look at the numerator there, this can be simplified further. This can be simplified. And how can we simplify this? By using the previous equations that we have here. So in this equation, we said the first set of brackets should have a minus in between. The second set of brackets should always have plus in between them. So this is what we're going to do. So we have 2 outside, and then the first set of brackets will have x minus 3. Then the second set of brackets will have x squared, and then plus 3 times x, which is 3x, then plus 3 squared, which is 9, according to this expression here. That's why I was saying you have to master this expression. Then the denominator we have is x squared plus 3x plus 9. So when you check the numerator here, part of the numerator there is exactly the same as the denominator, which means we can cancel those two. And the only part that we're going to remain with is 2x minus 3. So this is exactly what you're going to remain with. Okay, let's look at another expression that we have here. So we have 7 minus y, and down here we have y squared minus 49. So 49 can also be written as 9 squared, or rather 7 squared. So the numerator will still be 7 minus y, and then the denominator can be written as a difference of 2 squares. Remember, if you have a squared minus b squared, this is just the same as a minus b times a plus b. So when you have y squared minus 7 squared, this is just the same as y minus 7 times y plus 7. So now we further simplify this. So the numerator can be written as negative open brackets. We have y minus 7. So I've done this. I've just factored out negative 1 from the brackets. So I've factorized negative 1 from the brackets in case you are confused or about what I've done here. Or let me just do it step by step so that you know what is happening. So on the numerator there, I have negative y. I want it to look like one of these functions down. So I have negative y plus 7. So now, and the denominator there, we have y minus 7 and y plus 7. So on the numerator there, I want to factorize this minus because the y that is down there doesn't have a minus. So I factorize the minus 1 there, or the negative 1. I'm going to remain with positive y there. Then here, if I factorize negative from positive, I'll have a negative there. So I have 7. Then down here, I'll still have my y minus 7 and y plus 7. So when you multiply this negative 1 throughout the brackets on top there, you discover that you go back to this expression. So what you do is you now cancel out what is common. This part and that part are common. So you cancel them out. And whatever that you're going to remain with is what you write as your answer. So you have y plus 7 there as the solution. So this is a very simple question I'm sure you have seen. So mathematics is simple. We proceed to the next question. So let's look at equations and equalities. Okay. So we're going to look at equations and equalities, and then from there we'll also do some examples. Okay, so equations contain one or more variables. So for something to be called an equation, first of all, it needs to have an equal sign here in between. It needs to have an equal sign somewhere. And then apart from that, it will also have to contain a variable. Yeah, so this is what we have as an example of an equation, because there's a variable there. You can have two or more, or I mean one or more variables in one equation, and you also need to have an equal sign there for it to be an equation. So we have this one, we also have this other question here. It's also an equation. Even this part where we have two variables, x and y, is also an equation. You also have this quadratic equation. So these are some of the examples of equation. So the number that satisfy the equation, the numbers that satisfy the equation are called solutions or roots of the equation. So when you have been asked to solve this question, 2x plus 3 is equal to 8. So the solution that you get after solving this equation is known as the root of the equation in the case of quadratic equations. And then and in the case of these linear equations, you call them, you call the solution as, yeah, it's actually just the solution, or sometimes called the root of the equation. So when we divide by 2 on both sides, the value of x becomes what? 5/2. So this 5/2 is the one that we're calling the solution of this equation, or you can call it the root of this equation here. Okay. So the following equality properties are useful in solving equations. So some of the points that I'm going to show you right now are very important when you're dealing with equations. You need to know them. So one of the properties that is very important with equations is that whatever that you do on the left side of the equation should also be done on the right side of the equation. Okay, let me just put up the properties so that you see them. So the first one is called the reflexive property. Yeah, so the reflexive properties, this one is straightforward. You just have to understand that when we say 2 is 2, 2 will still be equal to 2. So when you say A is equal to A, it means that A is equal to A. Yeah, so this one is straightforward. Yeah, so let's look at the second one, which is A is equal to B. So when we say A is equal to B, it doesn't matter whether you start with B and say B is equal to A. These two statements are the same. So when A is equal to B, it means that B is equal to A. That's the way it is. So this one is called the symmetric property. And then there's also what is called the transitive property. So for the transitive property, you have to understand that if we say A is equal to B, and then we also say B is equal to C, this implies that, oh, sorry, I have to write C this side. We say A is equal to B and we say B is equal to C. This implies that A is also equal to what? C. So this is also a very simple property. It's not difficult to understand. What you just need to know is that if I say that A is equal to a dog, if we say A is a dog, and then we also say that B is also what? B is also a, if we say A is a dog, and then we say that, and then we also say that this same dog is equal to what? Is equal to C. What best example can I give? Okay, let's just use these same letters here. If I say A is equal to B and B is equal to C, it means that this A is also equal to what? C. Yeah, so this example I was giving here, but if we say A is equal to dog, it means that, if you say A is a dog and this same dog is C, it means that A and C are both what? They are both dogs. That's what it means. Yeah, so that's the meaning of transitive property. We also have this unknown property here. It doesn't have a name, but this is what I was trying to explain, where I said if you have A is equal to B, and then you decide to add C on A, it means that if this is called an equation, or if this is an equation, it means that the same C that you've added this side, you also have to add it on the other side. If we decide to multiply A if we decide to multiply A with C, it means that B should also be multiplied by C. That's a property, that's one of the important properties of equations. So if you decide to subtract something from A, you say A is equal to B, and then you decide to subtract something from A, you say A minus B, or minus C. This should also be done on the right. So if you're adding or subtracting anything in an equation, we call that thing as the additive inverse. If you are multiplying, it's called the multiplicative inverse. So what I mean is, if for instance, you have 2x plus 3 is equal to 9. 2x plus 3 is equal to 9. And then you've been taught to use, or let me say the right way to solve this equation is you find the additive inverse of the left side. So when you add it to the left side, you also need to add it on the right, to the right. So what this means is that I'm going to find the additive inverse of 3. So the additive inverse of 3 is negative 3. So I'm going to say 2x plus 3. The additive inverse of 3 is negative 3. Since I have added negative 3 on the left, I'm also supposed to do the same on the right. So I'm going to add negative 3 on the right. So this simplifies to, this part gives us a 0. So just remain with 2x, and this is going to be equal to 9 minus 3, and this is giving us 6. So from there, we can now find the inverse of 2. So the inverse of 2 is simply just 1 over 2. The inverse of 2, since we have multiplied the left side with 1 over 2. Okay, let me write it here. So we have 2x is equal to 6. So we find the inverse of 2. The inverse of 2 is simply 1 over 2. So we're multiplying 1 over 2 on the left. So since this is an equation, we also have to do the same on the right. So we have to multiply by 1 over 2 on the right. So this is the right way of solving questions. It's just that we are used to the normal way of saying, no, you just take this 3 to the other side of the equal sign. It's not like that. You need to apply the additive inverse. And then when you have such a question here, like a question like this one here, you don't just say we divide by 2 on both sides. No, you need to apply the multiplicative inverse on both sides. So this 2 and that 2 cancels, and you remain with x. So on the other side, you have 6 divided by 2, and the answer is 3. So this is the right way of solving questions, such that we are used to the normal way of saying things. Yeah, so we move on. So this is how you apply these properties when you're solving equations. So let us apply the same properties when solving these examples. Okay, before we can even, okay, we have examples there. Okay, so the other thing that you need to understand is that for something to be called a linear equation, it means that the power of that equation, or the degree of that equation, is 1. The highest degree of that equation is 1. What do I mean when I say the highest degree of that equation is 1? I mean, the power of x here, the value of n is always supposed to be 1, and a should never be equal to 0. So when you have anything that is in this format, this is called a linear equation when n is equal to 1. So when you just decide to change n to any number, let's say 2, this one becomes a quadratic equation. When you change it to 3, it becomes a trinomial, or you can call it a polynomial. Even a quadratic equation is a polynomial. So any number having the value of n greater than 2 is called a polynomial. So when it has n being equal to 1, if it's in this format and the value of n there is equal to 1, then it's called a linear equation. An example of a linear equation is what we have here. So let us now solve this linear equation that we have. So 2x plus 3 is equal to 7. So solving this using the normal procedure, following the steps properly, you say 2x plus 3 is equal to 7. So we find the additive inverse of 3. So we have plus 3 minus 3. We do the same on the right, we add minus 3. So this will give us a 0, we remain with 2x. Then this other side, we're getting 4. So we find the multiplicative inverse and apply it on both sides. So this and that cancels. We have x there, which is equal to 2. Yeah. So whether you use these normal steps or you just follow the normal way you like solving questions, you still be given full marks. Yeah, so you just say 2x plus 3 is equal to 7. Then you say 2x is equal to 7 minus 3. 2x is equal to 4 divided by 2, and x is equal to what? 2. So whether you follow this short procedure here or you follow this normal procedure here, you still be given the same marks. Yeah, so I'm trying to use these steps because we have learned and you need to apply them. Okay. So we also have this simple question here. Yeah, so this simple question just requires us to simplify. So the first thing that we need to do is to multiply 4 throughout the brackets there. So we have 4 times n, that will give us 4n. 4 times negative 2, that will give us negative 8. Negative 3 times n, you have negative 3n. Negative 3 times negative 1, we have positive 3. Then we say this is equal to 2 times n, that will give us 2n. 2 times 6, that will give us 12. So we just pair the like terms. So 3n, 2n, and 4n, negative 3n, and 2n, we put them together. So we have 4n, negative 3n, and negative 2n. Oh, sorry for that. Okay. Okay, we had, what is happening now? Okay, so we had 4n minus 8 minus 3n plus 3 is equal to 2n plus 12. So we put the like terms together. We have 4n minus 3n minus 2n. And this other side will have 12 plus 8 minus 3. So we have 4n minus 3n. The answer is n. N minus 2n, we have negative n being equal to. So 12 plus 8, that is 20 minus 3. The answer is 17. So we divide by negative 1, divide by negative 1. The value of n is negative 17. So these equations are simple. We also have this simple equation here. So the first thing that you need to do is to find the common denominator this side. The common denominator where 4 and 6 can go into is 12. That is the smallest. So 4 into 12, the answer is 3. 3 times x is 3x. 3 times negative 1, we have negative 3. Then we have this minus there. I'm going to put it there. Then we have 6 into 12. The answer is 2. So 2 times x there. Okay, let me put 2 here, and then I'll put x minus 2 in brackets. Well, let me do the same even for the first one. So I said the common denominator is 12. 4 into 12, the answer is 3. Open brackets, we have x minus 1 there. Then we put this minus there in between. Then we say 6 into 12, the answer is 2. Open brackets, we have x minus 2 there, which is this part. Then we say this is equal to 2 over 3. Okay. So from there, we can open the brackets. So we are in the last 1 minute. So once the link ends, you have to join using the same link so that we finish up the remaining questions. So we have 3 times x, the answer is 3x. 3 times negative 1, the answer is negative 3. Then negative 2 times x,